Hi everyone. In this video, we are going to see an example of application of Bernoulli's principle. We consider here a beaker that is open to the atmospheric pressure P0, which contains water. A hose has one of its ends placed in the beaker at a depth h and a height h1 above the ground. The other end is in the air at a height h2 above the ground. We want to determine the speed of the water as it flows out of the hose. We are going to take here the usual standard atmospheric pressure, which we need to convert into pascals. The difference in height between the upper and the lower end of the hose is 3.5 centimeters, which in meters is 0.035. The depth at which the bottom end is in the water is 8 centimeters. We are going to consider here a hose that has a diameter of 5 millimeters at the bottom end and 3 millimeters at the top end. The first thing we need to do is to determine the pressure at the lower end of the hose, and for this we use the formula for the pressure at depth. P1 equals P0 plus rho gh. The pressure at the top end is just the atmospheric pressure, so P2 equals P0. Now we are going to use the continuity equation, A1V1 equals A2V2, and we are going to relate the cross-sectional area A to the diameter of the hose, since this is what we are given. So the area of a circle is pi r square, and as you know, the radius is just the diameter divided by 2. So when we take the square, we get a 4 at the denominator. As a result, the continuity equation can be written as d1 square v1 equals d2 square v2. Next, we consider the Bernoulli equation, p1 plus 1/2 of rho v1 plus rho gh1 is equal to the same quantities for the second variables. Now, we just showed that p1 is p0 plus rho gh, and also p2 is just p0. So what we can do is to move all the velocity terms to the right-hand side and all the other terms to the left-hand side. So we obtain g times big H minus h2 minus h1 is equal to 1/2 of v2 square minus v1 square. So we have two equations with two unknowns, v1 and v2. And what we want to find is v2. So v1 is the unwanted unknown, and as usual, we solve the easiest equation for the unwanted unknown. So we write that v1 is d2 square v2 over d1 square. And then we substitute into the Bernoulli equation. We end up with an equation that contains only v2, so we can solve for v2. And we find that v2 is equal to the square root of 2gh minus h2 minus h1 over 1 minus d2 to the 4th power over d1 to the 4th power. Plugging the values in, we find that v2 is equal to 1 meter per second.